let's continue with the remaining part of our data structure. So previous lecture we have seen the data structure and its types in basic brief. Now we can see this in a details. So if we consider type of a data structure, so we have two data structures, primitive data structure and non-primitive data structures. A primitive data structures are a data structure which holds the primitive data types like integer, character, float, double. So these comes under a primitive because it holds a single value. So non-primitive data structure is the data structure which holds the multiple values. As we seen array. Array holds the multiple values into a particular one name. So we can call it is a non-primitive. So here in non-primitive, array, stack, queue, linked list will come into existence. Now if we see with the use of how it stores in a memory or how we can access it, arrange it, for that we have two again types, linear data structures and non-linear data structures. Okay. So if we see linear, it is very important to understand linear data structure are arranged sequentially, and we can call it is a data structure where data items are arranged sequentially or linearly. So where each element is attached to previous and the next character. So we can able to fetch the data easily because we store and arrange the data. We cannot say store. So we can able to access the data sequentially, arrange the data sequentially. So here are the example where we access the data or arrange the data sequentially are the arrays, stack and the linked list. So these are the important data structure which comes under linear data structure. There is one more example of a non-linear data structures. So non-linear data structures are the data structure which is not organized sequentially or linearly. So we call it is a non-linear data structure. So it is very easy to understand. Linear means sequentially we arrange. Non-linear means we are not arranging sequentially. So it is called a non-linear data structures. So why we cannot access it sequentially or arrange sequentially? Because here the single level is not involved. We have multiple levels. So we cannot traverse all the elements in a single run. So we can have multiple different ordering methods to access the data. So for the example comes under non-linear data structures are trees, graphs. So these elements comes under these data structures are non-linear. So here are few examples to understand the data structures. So first one is array data structures. Array data structure is, if we call array, the definition of array is it is a continuous memory allocation as well as it helps us to store a data of a same time. So array is able to hold multiple data items together, but one drawback of it is it's able to store only a same data type. So array able to hold a same data type into a single unit. So here if we understand this array, so first one there is an index. Index begin with a 0. So first element if I wanted to access, I can access the 0 index. And the last element I can access with the n minus 1. So if I am storing 10 data elements, I can store that with the n minus 1, means the index of my last element is, if I am holding a 10 elements into array, the last element is n minus 1, means a 10 minus 1, it is a 9 elements. If you see, the last element index is a 9. So here the array length is a 10. So we can see this further in the slide, remaining part of the array. This is the basic overview of array. So if we see the next data structure is a linked list. So linked list is a very famous and important data structure. Why I am telling you this? Because linked list is we can able to create a linked list using a dynamic data structure. It comes under dynamic. So why it comes under mostly dynamic? Because we allocate a memory dynamically, means at a runtime. So there are keywords which help us to allocate a memory at runtime. Malloc, there is a keyword calloc. These are used to allocate a memory at runtime. There are other which is used to deallocate a memory, that is a free. Free is used to deallocate a memory. So these are the elements which we can access. Allocate a memory at runtime. We can delete a memory at runtime. So here if we see in a linked list, we are having the head node from which our execution of the linked list will begin, and there are multiple items into this. So we can see this in the next lecture.